Lesson 3-6, solving equations and formulas. In this lesson, you'll solve equations and formulas for a specified variable. Let's take a look at this integration in geometry. Some equations contain more than one variable. At times, you will need to solve these equations for one of the variables. For example, suppose the variables x, y, and z were all in the same equation. To be able to solve for x, okay, would mean to get x by itself on one side of the equation. Again, to be able to solve for x, if you have variables x, y, and z in one side, would mean to get x by itself on one side of the equation, okay, with no x's on the other side. So the x should be on one side, no x's in the other side. In the same way, to solve for y, you would mean that to get y by itself on one side of the equation with no y's on the other side. Okay, so remember that this is a good starting point, okay, when you're trying to solve, or we're trying to solve an equation where you have more than one variable in your equation. Okay, knowing that, let's take a look at the formula of a triangle. We know that area equals 1/2 base times height, where b represents the base, obviously, and where b represents the base, the length of the base, I'm sorry, and h represents the height of the triangle. Okay, suppose you know the areas and the lengths of the bases of several triangles, and you want to find the height of each triangle. Okay, so basically what it's saying is this: you already know the area and you're given the base. You want to find the height. Okay, so rather than solve the formula over and over again for different values of a and b, it would be easier to solve the formula, okay, for h before substituting the values for their variables. Okay, and let's do that right now. And then again, we go back to area equals 1/2 base times height, and we want to solve for h. Remember, in order to solve for h, we need to isolate h on the right side, and we need to undo 1/2, and we need to undo b, meaning we need to get b to the other side of our equation. So in order to do 1/2, we simply multiply both sides by 2. Okay, multiplying both sides by 2, you end up with 2a equals 2 times 1/2 bh. Okay, doing that will get rid of your 2, so you end up with 2a equals bh. Okay, again, you want to solve for h. We want to undo b, and bh is a multiplication operation, and in order to undo b, we divide both sides by b. And if you divide both sides by b, end up with 2ab all over b will be equal to h. So to be able to find your h, your height, given your area and your base, all you need to do is follow this formula for h. Okay, so when you divide by a variable in an equation, remember that division by 0 is undefined. For example, in the formula above, b cannot equal 0. So in this case, even though you have this formula, you need to have a restriction saying that b cannot be equal to 0, or else that number would be undefined. Let's take a look at example number 1 and see how this works. Solve the equation negative 5x plus y equals negative 56. We need to solve for y, okay, for this equation, and for letter b, we need to solve for x. Let's solve for y first. So solving for y, we have negative 5x plus y equals negative 56. Okay, in order to undo negative 5x, okay, and isolate y on this side of the equation, we simply add 5x to both sides. If you add 5x to both sides, negative 5x is undone, and we have y equals negative 56 plus 5x. We have solved for y. We've isolated y on this side of the equation. Okay, and now let's solve for x this time. Again, copy the problem, negative 5x plus y equals negative 56. We want to isolate x. Okay, that means we need to undo y and we need to undo negative 5. in solving two-step equations, okay, and working backwards, we undo addition first before we undo multiplication. So we subtract y to both sides. Subtract y to both sides of the equation, we end up with negative 5x, okay, equals negative 56 minus y, because y minus y will give you 0. And then how do we undo negative 5x, which is a multiplication operation? We simply divide both sides by negative 5, and you end up with x equals negative 56 minus y all over 5, or 56 plus y all over 5. Okay? Why? What happened there? Why are these two equal? Because look at this one. Okay, you have negative 56 minus y all over negative 5. Okay, and if you notice, okay, I can actually simplify this to become, using the distributive property, negative 56 plus y all over negative 1 times 5. Okay, I can even put negative 1 here. Okay, taking it one step further, I simply cancel out that 1. I end up with 56 plus y all over 5. And that's why I end up with that one. Those two are equal. Okay, let's take a look at example number 2. See how this goes. Solve for y in 3y plus z equals am plus 4y. Now we have a lot of variables, but we're only asked to solve for y. Okay, and in order to solve for y, okay, we have y here and we have y there. First and foremost, let's copy the problem down. We have two y's. Both y's are on both sides of the equation, so we need to put them all on one side to be able to solve for y. Okay, so before we do that, okay, let's undo. Let's think about where we want to isolate y. So in this case, we want to isolate y on the left side of the equation. That means everything else should move out and move to the right side, or undo everything else on the left except for y. Okay, so the first thing we need to do is undo z, and we subtract z to both sides of the equation. Subtracting z to both sides will leave you with 3y equals am minus 4y minus z. Remember, they are all unlike terms, so you cannot add or subtract them. Okay, now that we have done undone z, now we need to move this y, move it to the other side. Okay, move it to this side of our equation. And how do we do that? We simply add 4y to both sides. If we add 4y to both sides, this negative 4y will go away, and you now have 3y plus 4y equals am minus z. Okay, because the 4y minus 4y equals 0. Now we have 3y plus 4y. Now we have like terms. Adding your like terms, you have 7y equals am minus z, and then simply solving for y, we divide both sides by 7, end up with 7 equals am minus z all over 7. Okay, so that is now the value of y when you have 3y plus z equals am minus 4y and you're trying to solve for y. Okay, another good use of this particular lesson is what we call dimensional analysis. Many real-world problems require the use of formulas. When using formulas, you may need to use dimensional analysis. You may also be asked to solve the formula for a specific variable. This may make it easier to use in certain formulas. This is a very interesting formula because your parents or your mom probably uses this every single day. The formula P equals 1.2W all over H squared represents the amount of pressure exerted on the floor by the heel of a shoe. In this formula, P represents the pressure in pounds per square inch right there. Okay, W represents the weight of the person wearing the shoe in pounds, and H is the width of the heel of the shoe in inches. Okay, so what does this formula represent? It represents the amount of pressure being exerted, okay, by the heel. Okay, and most of the time it's on an object. So the amount of pressure being exerted by the heel, okay, can be measured by this formula. Okay, so let's take a look at example A. Find the amount of pressure exerted if a 130-pound person wore shoes with heels, okay, 1/2 inch wide. Okay, so we want to find out the pressure exerted. Okay, in letter A, you know the weight of the person, you know the width of the heel. So basically in the formula, you already know the W, okay, and you already which is the weight, and you already know the H, which is the width of the heel. Okay, and letter B, it's asking you to solve for the formula for W. And letter C, find the weight of the person if the heel is 3 inches wide and the pressure exerted is 40 pounds per square inch. In letter C, you notice that you're given the pressure, okay, but you don't know the weight of the person, but you still know the H. Let's take a look at letter A. Following the formula, we simply substitute the values. Okay, 1.2 times 130, which is the weight of the woman, multiplied by, I'm assuming it's a woman, multiplied by 1/2, okay, 1/2 squared, okay, because you are squaring the width of the heel in that case. So you end up with 156 pounds over 1/4 square inch, or simply, okay, 1/4, 156 over 1/4 is the same as 156 times 4 will give you 625 pounds per square inch. Okay, so in this case, the pressure exerted by a woman that weighs 130 pounds and the width of the heel is 1/2 inch, 1/2 of an inch, would be 625 pounds per square inch. That's a lot of pressure for a 130-pound woman. Okay, and letter B, solve the formula for W. That means we need to isolate W on the right side of the equation and undo H squared, and we need to undo 1.2 as well. So doing that, we need to first undo H squared. That means we need to multiply both sides with H squared. That will undo H squared. You now have H squared P equals 1.2 W. And in order to solve for W, okay, this remains a one-step equation. We divide both sides by 1.2. We end up with W equals H squared P all over 1.2. The reason why we solve for W, because in letter C, we're trying to find the weight of the person. Okay, and just by using that formula now, W equals H squared P all over 1.2. Okay, we end up with substituting the values for H, which is 3 inches. Okay, square it. Pressure is 40 pounds per square inch over 1.2. Okay, you end up with B, 360 pounds over 1.2. Okay, now you might be asking, whatever happened, okay, whatever happened to the other units? Okay, remember, when you have inches squared right here, okay, and pounds per square inch, let me rewrite that so it'll be clear to you. Okay, and that's why we call this dimensional analysis. Inches squared, and then you're multiplying it with pounds per square inch. Okay, you notice that when you multiply these two units, the inches squared disappears. It cancels itself out, and that's the reason why you're left with only pounds. Okay, so doing that, you have 360 pounds all over 1.2, and you end up with 300 pounds. So the person weighs 300 pounds if she exerts a pressure of 40 pounds per square inch and her heel width is 3 inches. That's a pretty heavy individual. Okay, and that is the end of our lesson on Google Forms or My Big Campus. Type a summary of what you've learned by responding to the objectives of the lesson, and type a question you may want to ask in class. Thank you.